We'll continue. Bruce.
Do you have some cookies?
Any cookies?
No.
No taste cookies.
Brian?
You know this tastes like it.
Brian. Brian has.
No, that's his lunch. That's different.
That's not his lunch.
That's his lunch.
That's a snack. That is similar to
Oh.
What is that passing around?
chocolate.
Chocolate.
How nice, how nice.
Oh.
Yeah, beer is in it. It's really good.
Nice,
No.
nice.
3% peanut beer. Don't get drunk.
Is it peanut chocolate?
Yeah.
Can I try one? What
Yeah.
is it?
Thank you.
Thank you.
You're a minor.
There's a
Can you help?
Where'd you get them?
Can you have this?
Beauty shop?
Okay.
That's mine, favorite.
Oh.
Not Jerry's. Okay. Okay, which one do we need to see in projectiles first? Number 3, is it?
Yeah.
Projectiles.
Yeah, number 3.
Just
B.
the B part.
Yeah.
Okay. So, here the height is 0.9 meters, and it moves in the air like this. And do I give you info about the, yeah. This goes at 44 meters per second, and this angle here is 40 degrees. So this here is 44 cos.
Cosine 40.
Yeah.
Sine 40.
Okay. What's happening here is there's 3 forces acting on it, I believe. You have a downward weight of 1 Newton. Yep. Then you have, while it's here, a force this way of 0.1 newtons. And another force down here of 0.1, and this is while it's moving up.
Where? 0.1.
It says in the question, doesn't it?
Which has
3B. I'm just looking at the B part here. Yeah. Now, what happens on the way down? Well, on the way down, you still have the weight. You still have this force backwards. But now, that 0.1 acts upwards. Because it's heading down. Yeah? So, unfortunately, we're going to have to break this up into 2 problems. So let's, what are we looking for? The range. So we have to find Sx of the first and the second part. Okay. Let's get the time here to the maximum height. U, V, A we don't know. Now to work out the A, we have to use Newton's law. So we'll say it's F over m, which will be minus 1.1 over 0.1019. What's that, please? And it should be more than 9.81. $10.79. Yeah? 795. Okay. And we would like the T. Okay, so what's the T here? How can we get that? just V equals U plus AT, right? So 0 equals U plus AT. So the T will just be the U, 44 sine 40, divided by that number you have on the calculator. 2.62 seconds then. Okay. Now what's the only difference in the second part here? Well, the only difference in the second part, if we look vertically, the U vertically is 0. The V we don't know when it hits the ground here. The A we can work out, but this time it'll be 0.9 over 0.1019, which we can work out. The T I would like to know, and the S is something I know here. The S is... Oh no, do I know it? No, I don't know it. I feel like I'll have to work out...
But teacher, A is not that. A is S plus W over M.
0.9 over M? No?
0.2 over.
0.2?
Yeah, because W is
No.
0.1.
How'd you get 0.2?
W is 0.1 and
W is 0.1. No, W is 1.
Huh?
What?
What are you doing, Monica?
No? Oh, okay. And Fy is 0.1. Therefore it's 1.1.
What are you asking me?
Where are you?
I mean, that's A is, it should be S plus Fy.
Okay, can someone just tell me what 0.9 divided by this is, and we'll check if it's the same as yours. 0.9 divided by 0.1019. 8.83 with a minus. Why is this a smaller number on the way down? Yeah, but why is this less than 9.81? Yeah, but why is it... The force upwards is helping to reduce its downward motion. So I think it would be quite nice if I work the S out here. I think it would be helpful for the second part vertically. So what will we go with? S equals, so if you can hit this in your calculator please, S equals U T plus a half A T squared. That's okay, I forgive you. You're forgiven. Did we get the S for the first part? You got an S for the first part? Can somebody else confirm?
Yep.
Yeah? Okay. So can somebody tell me for the second part what's the S here? Vertically for the second part. Now say with confidence now, because you might be right. What is it? Go for it. Close. 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 9.5. Yeah. Why? Yeah. If it starts here and finishes here, that's displaced by minus 37.95. Okay, let's get the T now. Well, give me the T. F equals UT plus a half A T squared. Great. So the T here will be 2 times 3.795 over 8.83 square root. What's that time? What is it? Jerry, do you have a calculator? Well, help me, come on, what's this? No, I believe in you, tell me what this is. 2.93 plus 2.62 gives me the total time. Is that 5.55?
Yep.
Seconds. Now we can finally answer the question about the range from here to here. U equals 44 cos 40. V we don't know. A will be minus 0.1 over 0.1019. T is 5.55. And the S is what I want. So S equals U T plus a half A, well, plus a half A T squared. Okay, so what is this coming out as, please? 44 cos 40 times 5.55 minus fraction 0.1 over 0.1019 times 2, because it's a half, times 5.55 squared, 172 meters. Yes. 172 meters. I know. It's a pretty difficult question. Pretty difficult. Yes? Yeah. How far are they? More? Can you see that? Okay. There's an awful lot there. You can always watch the video later. I've been on 199 subscribers for the last 5 days. Somebody help me out here. I'm just one away. Okay, did anybody get this? The whole journey for B. Unfortunately not, because the force changes direction in the middle. You see, at the beginning, Jerry, at the beginning when it's going up, the force is this way and this way, but then when it's heading down, the drag is this way and this way. Because of this change, we have to do it in 2 parts. Okay. 172.
How far is the distance of this place?
How far is, in this question I mean displacement. Yeah. Okay, what's next? The whole thing?
Yeah.
The whole thing? Okay.
Four.
4? For real? There is no. Oh yeah, 7 is there, yeah.
You have to do 7.
You do have to do 7.
Is it center where it's going down?
Yep, that's why I put it in.
I mean the whole of our second section where similar level of our downward.
These? Question? question 3 and question 6 are the hardest they could be, and I've only seen question 6 once in the exam.
At
So-
least you still won.
Huh?
At least you still won.
Well, that's the good news, I suppose. It's not a common type of projectile question in the exam. A very common one is something like number 2, this type. You know, I would say 90% of the questions will be of difficulty like number 1 and number 2. A small or number 5, 1, 2, 5. A small number of them will be like number 4, and only once have I seen something like 3 or 6. Which isn't actually bad, it's good news, because, you know, I'm talking about like 10 years of exams, 2 exams a year, so 20 exams, I've only seen one that difficult once. But the point is, I have seen it, which means it could be on the exam. But good chance is you'll get a question more like number 2. So I'll do number 6, in case you get something like it. Yeah, can I scroll down? Yeah. You think? Okay.
Number 4.
Okay. After number 6.
Can we please like
I don't know. We might have to carry some over to next week. We'll see. What angle is this at? Did I say 45? And this angle? No, that's 60 to the horizontal. Yeah, so this extra piece here is just a 15. Because it's 60 in the picture for the whole thing. Do you have the picture there? Can you see? It's 60 to the ground. Okay. Well. And let me just stick in here, I'll just say G, gravity is here. And the projectile goes up and then down like that. And this is where the maximum height is, and then this is where the end is, okay? Now the trick here is you still have to resolve it, but in your mind you have to be kind of happy with placing this as the x. Now you see, you're turning your head, but don't worry, I'm way ahead of you. So I've turned it for you, okay? So you see, in this picture here, you might think, oh, this is just like a normal problem. I just resolve. Did I give you the speed here? 15? Okay. Oh, 50. So this one here is 50 cos 15. And then this one here, 50 sine 50, 15. But what's different in this world, the G doesn't act perpendicular to the x-axis. It acts at an angle to it. So we should resolve the G as well. So if that's 45, then this is 45, and if that's 45, then this is 45. So I just need to move my G to make it a bit clearer. My G was originally here, so this one is G cos 45, and this one is G sine 45. Yeah? It's okay so far. So before I continue, and I know I know it doesn't look it, but this should be a perpendicular. Okay, it's a bit better. Right, so before continuing, is there any questions here? Now, this is the same problem. You just drew the xy in a different location. But it doesn't matter. You can put the xy axis anywhere. So before continuing, is there any questions? I don't know if this is blowing your mind or something because you can see it turning. Whoa. Are we good with this or is it confusing? Looks so confused.
Why is it that?
Yeah, because if I didn't, I mean, if I want to know something like, say, the range, that's usually when it hits the ground. That's usually when s equals 0. In this picture here, if I didn't, then this is the end of the flight. The s is not 0 here. I would need to work out this. How would I work this out? Well, I would need to know what this is. But I don't know anything here. I know nothing. Instead, if I draw the x in a different place, if I make this the x-axis, then now I can say s equals 0 here. But in this picture here, if I put the x-axis here, the s is definitely not 0, in something I don't know. So this is the motivation for it. It lets me do the problem like I was doing it a moment ago. Yeah? So, tell me, if I want to get the time to the maximum height, UVATS. Now, I won't do each part because it's just UVATS, but I just want to make sure you know what the UVATS is for each part. So if I'm looking for the time to get to here, what should I use for the U?
50 sine 50.
The V?
0.
The A?
Negative 9.81.
No.
Oh, okay.
Now, why am I saying that? Yeah, I'm only looking in the vertical. The Y. Yeah. What's the T? Is what I want. I have enough info here. No, we won't work it out because it's just a simple matter now. So you can work out. Could you work out the T now? Is it possible to? Yeah, it's possible. Okay. Now, part B, what is the maximum height? How would I get this? Maximum height.
Find S.
Find S, and that's it. Okay. C, what is the time of flight? Okay, so that's a bit different now.
S equals 0.
S equals 0, and this now, you don't know. You don't know. Yeah? Okay. How do I get the range now? Okay, so I want the range. What should I use for UVATS?
Oh, for that, right? Isn't it V equals 0?
Here? No.
What about
That
50 sine 50?
if we are finding the time of flight.
Oh yeah, that's why I wrote it over here for the next part.
Oh.
So what will I say now for UVATS? For the range. 50 cos 15. V? Don't know. A?
Negative G over square root 2.
Yeah. T is whatever I got previously. And the S is what I want. For getting the range. Okay, the next part is the final velocity. So that just means I have to work out the V. Look, that just means I need to get the V here, and I need to get the V here. And then I have the final velocity. I have the velocity when it hits the ground. This way and this way. That's the Vx, and the other one's the Vy. The next part, how can I get the speed? How do I get the speed? And I know the Vx and I know the Vy. How do I get the speed? Yeah, how do I get the speed?
I can do it.
No. Oh, come on, you couldn't have forgotten. How do I get the speed? Use. Ah, you do know. Shit, what's his name? You know his name. You couldn't have forgotten. It begins with a P. Now don't look at him. He doesn't know his name.
Sometimes you said VI.
Yeah, what's it called? Pythagoras.
Yeah.
Yeah, that's the one. Pythagoras. Okay. Yes, and the last one is, how do we get the angle here? The direction? Well, that's just the usual tan inverse the y1 over the x1. Now, I didn't go through it because it would take quite a long time. I think the difficulty here is understanding the picture. I hope you understand the picture a bit better. Don't freak out if you didn't, because it was very hard, but maybe you should try it again this weekend, perhaps. Yeah. If it's still a problem next Friday, I will do it out fully, okay? But I believe that you can do it. Alright. Let's have a look at... That's not quite right. Okay. 4. You watch a football game and the person kicks the football.
No, I did it.
Okay. So it's okay now?
Yeah.
Alright, great. Alright. Okay, I like these questions then. Right, next now. Which one?
Number 3.
3AB.
Also is wrong.
Are you sure?
Yeah, for that reason, it's not true.
The answer is wrong.
We don't try to see the numbers.
But I want you to do this type of...
Tell me what I did wrong.
You put number wrong.
That was it?
Yeah.
What number did I put in wrong?
I don't remember it, but if it is like 0.123, you put like 0.23 like that.
Oh.
So
And you saw that in the video?
No, I do like, why you got this answer, so I tried that way and I got that answer. But I tried my own way and I got
Okay, so it was a input error on my part. That's fine. So if you're all confident that I did it wrong and you actually know what the mistake is, do you need me to do it? Do you want to?
That's also
But for me, just do it.
What?
For me, just do it.
Yeah, I'll do it. You know, it'd be funny if it was right.
And are you gonna do number 4?
impossible.
We'll see. We'll see. Okay. Number 3. 1.019 kg block slides along the ground by means of a rope pulling it under a tension of 2 newtons. Oh, parallel to the ground. The friction force is equal to 1/10 the reaction force, and the reaction force will equal the weight, which will equal 10 newtons, right?
1 Newton.
1 newton?
Yeah.
No, 10 newtons for the weight. The weight.
The weight is 10.
Oh, it's around. Yeah, it's 10.
It's 10 newtons. So the reaction force,
10 Newton.
10 newtons. So the friction force,
1 Newton.
1 Newton.
so 1 newton left, 1 newton right, total force,
1 Newton.
1 newton, which equals
A.
A. So the A is 1 over 1.019. What's that, please?
0.98.
0.981.
0. Oh wait, I was only asking for,
Acceleration.
why have I got in as newtons? That's a good question. Okay, what is it here?
0.981. 981.
981 meters per second squared.
Yeah.
Okay. Right, so I'll have to fix that. Well, maybe remake the video for that one then. 0.981. And now the second part, the only difference is that it's now at an angle. So now this here is a 2. So this side becomes 2 cos 20, is it? And now this one here, you also have the or plus 2 sine 20. Now that or plus 2 sine 20 still should equal 10. So what does the or equal? It'll be 10 minus 2 sine 20. What's that, please?
0, what?
10 minus 2 sine 20. 9.312. So that means this here is 0.9312. So that means the force now is not 1. Instead it will be 1.1798. No, 1 point. Hang on, let me try it again. 1 point. Yeah, no, that's right. 1 point. It's 2 minus this number.
We have that great force cosine.
Hold on. Can so? Oh no. Sorry, I realised what I was doing wrong. The total force is 2 cos 20 minus 0.9312. And what's that? 9482 newtons. So then, if I'm looking for the acceleration, I should divide this by the 1.019. So what do I get now? 0. 931. What did you get, Jerry?
It's because of the reaction
As this? I guess we were both wrong.
Actually, I saw your video. You write 1.019 G is equal to 1 Newton.
How embarrassing. How embarrassing.
The only difference is the R. If you use the R as 10 and you use 2 cos 20 minus 1, you get 0.8.
Why is R different?
Because of 2 sin 20.
Oh yeah, why does the or change? Because there's a vertical component adding to the or when it's at an angle. Yeah, I'll remake the video for that.
Okay.
Right, okay, so that's Newton's 3 laws. What else now?
Time is almost up.
Is it? Oh, japers. Okay, what else do we need to see?
Rocket science, all of it.
Number 6.
All of it. Wait, number 6. Rocket science, what number?
In which?
What number?
What?
Third law.
Yeah, which one?
Number
6.
6.
Yes or no? Will I do number 6? Is that a yes? Number 6? Yeah? Okay, number 6. 70 kg man stands on a weighing scale. It takes the elevator 4 seconds to move up 1 floor. Okay, let's get the A first. UVATS. The U, 0. The V we don't know. The A we don't know. The T is 4 and the S is 5. Yep, okay. S equals UT plus a half A T squared. So that means 5 over 8, 0.625. Is that the A?
Yeah.
Okay, so A is 0.625 meters per second squared. Now here's the man standing on the weighing scales. He feels 2 forces. Believe it or not, he feels the weighing scales pushing up and raising him up in the air. So the oar is down, the oar is up, the W is down. The total force is upwards though, because he's rising. So F equals oar minus W. MA equals R minus W. M is 70, A is 0.625, or we would like, and W is 70G. Yeah? So the OR is 70 times 0.625 plus 70 times 9.81. 700.45 like this? Alright, that's the reaction force. Now, how do Wayne scales work? Wayne scales work because they think the person on it is not moving, and in other words, they think the R is equal to the W. So, the Wayne scale thinks this is just mg and calculates the m from that. So, if I divide this by 9.81, I get what the Wayne scale thinks he weighs.
74.46.
What is it?
74.46
kg. So that's what the Wayne scale thinks his mass is. 4 kilograms more than what it really is. Likewise, when the elevator goes down, you'll get 4 kg less.
Easy.
I make it look easy. Thank you. Was that okay? Are you sure? Yeah. Wait, just before you go, just so I know what's outstanding for next week, it's only the rocket science then, is?
Yeah.
Which questions? For real?
Even get one.
3 and 4.
Not one.
Well, I hope you got number 1.
Number 1 and number 2.
Not one, man.
Number 1.
3 and 4. 3, 4, 4.
Yes, 3, 4, 5.
3, 4, 5.
The
1, 2, 3, 4, 5, 6.
Oh, we got number 1.
Hang on.
2, 3, 4, 5, 6.
2, 3, 4, 5.
Are you sure?
Yeah.
We watched the video, no?
And did I make a mistake?
No, I'm saying we watch. I will watch the video.
I see you messed up.
This is a rocket science, okay?
We'll see.
I think it's so much better to find the difference.
What we might do, yeah, okay, we'll have to see now for next week how you get on with the new topics. We'll do the rocket science in the tutorial next week, and then if we need more time, we can continue it in the second class then, okay? Here's the pencil, thank you.
So, power.
Can you do the homework?
Yeah.